All right, we have the second part of 2.4.0. I'm just doing the last three examples on that note sheet, so 9, 10, and 11. And again, remember, we are not taking any derivatives. We are simply just simplifying. Okay, so number 9. When I look, I see that I have two parts here. I don't have any fractions, so that's always a good thing. But I do have a negative exponent. So right now I got this x cubed and this x. So I'm going to take out an x out of each box. And I'm going to take out a 1 minus x squared. And you take it out to the lowest power. So I'm going to take out a negative 1/2. Okay, what do I have left over then? Well, if I take an x out of x cubed, that leaves me with a negative x squared. But then nothing else there because I took out that whole thing. If I take an x out of 2x, that leaves me with a 2. And it's very typical for right now that when you take out the negative power, you're going to be left with the power to the first. Again, you should be able to take this term, distribute it here, and then distribute it here, and get back to the original. So that negative 1/2 and a positive 1, when I add that together, I get that positive 1/2. So then I just have to simplify what I have in the brackets. So a negative x squared, this is going to give me a negative 2x squared. So I'm going to have 2 minus 3x squared. But you can't have a negative exponent. So again, be very deliberate about what's in the numerator and what's in the denominator. So my answer is going to be 2 minus 3x squared all over 1 minus x squared to the positive 1/2. All right, there's number 9. Okay, let's look at 10. So 10, I have negative fractional exponent, so that's a problem. And I also have a fraction, so that's a problem. So the first thing I always think of is that if I have a fraction in this part, I want a fraction in this part. So I'm going to change this 4 to really be 16 over 4, because 16 over 4 is 4, but now I have that common denominator of 4. Okay, so now I can take out the fraction, so I'm going to take out a 1/4. I have an x squared and an x, so I can take out an x. And then I can take out that x minus 3 to the negative 1/2. So again, I want that common denominator out of there, the x, and then always the lowest powered exponent. All right, what do I have left over? Well, if I take a 1/4 out of a 16/4, I just have a 16. If I have an x out of x squared, I just have x. And then that term is gone. In that second part, the 1/4 is gone, the x is gone, and if I take out something to the negative 1/2, but I need it to be a positive 1/2, that's going to leave me with just x minus 3 to the first. All right, so when I go through and clean this up, I have 1/4 x minus 3 to the negative 1/2. In the brackets, it looks like 16 minus x, I'm going to have 15x. And if I distribute that negative, I get plus 3. But now I cannot have a fractional exponent, a negative exponent. Okay, now again, be deliberate about how you're writing it, what goes in the top and what goes in the bottom. I have a 1 and an x is going to be in the top, and 15x plus 3 goes in the top. In the bottom is going to be this 4, and then that negative exponent that moves to the bottom. And then that's your answer. All right, we have one last example, this number 11, we're going to look at x. I am not really sure why they didn't put the x and the 2x together, but this is the problem. So if you notice, I put a box around that second part and the first part, because now I'm saying that there's two parts and I'm going to need a GCF. And when I look at this, I see that I have a negative fractional exponent, so that's going to be a problem. I also notice that there's a fraction here. So if there's a fraction on this side, I want to put a fraction on this side to keep everything balanced. So there's no coefficient here, so I'm going to make it 3 over 3. Okay, so now what can I take out of each box? Well, I could take out that GCF of a 1/3. I can also take out that x squared plus 4, and remember I'm taking it out to the negative power. So I'm going to take it out to the negative 2/3 power, because that's the lowest power. Okay, so what do I have left over then? Well, if I take a 1/3 out of a 3/3, I have a 3. If I take an x squared plus 4 to the negative 2/3 out of the same thing to the positive 1/3, that's going to leave me with an x squared plus 4 to the first. Again, you should be able to distribute that back and get back to this original part. So negative 2/3 plus 3/3 is 1/3. All right, in that second part, if I take a 1/3 out, that's gone. If I take an x squared plus 4 to the negative 2/3 out, that whole thing is gone. So that just leaves me with this x times that 2x. So that's going to be 2x squared. All right, lastly then, I just have to clean everything up. So in this bracket here, that's going to be a 3x squared minus a 2x squared. So that's just going to be an x squared. And 3 times 4 is 12. And then remember, I'm very deliberate about what goes in the numerator and what goes in the denominator. So here, this whole term is going to move to the bottom. So this 3 is already down there. And then I'm going to be left with x squared plus 4 to the positive 2/3 on the bottom. And that is your answer for that one. All right, the next section we get into now, actually taking derivatives and then simplifying them. But that's it for now on this. Okay, bye-bye.